Hello students, today's topic is unsymmetrical bending. This is unit 4 of mechanics of solid part 2. In today's lecture I will include what is unsymmetrical bending, the different cases of unsymmetrical bending and how it differs from simple bending. So let us start with the definition of unsymmetrical bending. In unsymmetrical bending, it involves the cases in which either bending moments do not act in a plane of symmetry of the member, or the member does not possess a symmetrical cross-section area. I will revise it. Here I have explained 2 points. Number 1, bending moments do not act in a plane of symmetry of the member, and the second part is the member does not possess a symmetrical cross-section area. All of you know that what is a symmetry. What is symmetry? We know. Just like rectangle has 2 axes of symmetry. Symmetry means when we fold in 2 parts and either the 2 parts will overlap each other, then we can say that this is a 1 axis symmetry or 2 axis symmetry. We find that rectangle, circle, square having 2 axes of symmetry, and if we say semicircle, it will have a single axis symmetry. So the 2 things are bending moments do not act in a plane of symmetry of the member, and second one is symmetrical cross-section area. Just revise what we have taken assumptions in case of simple bending. Simple bending, or the derivation of the formula of simple bending, sigma by y, m by I, E by r. So different assumptions are: material is homogeneous and isotropic, transverse plane remain plane after loading, and beam is straight and all filaments are bent into circular arcs, out of which there are many assumptions. The most important one for the case of unsymmetrical bending is that in simple bending, this is the assumption of simple bending, but it will differ. It will help us to understand what is unsymmetrical bending. Is that section is symmetrical about a vertical plane passing through the vertical axis of symmetry, and bending moments acts in that plane. This assumption we can better understand with the help of these diagrams. I will explain you what is unsymmetrical bending with the help of these 2 diagrams. What is our assumption in case of simple bending? Section is symmetrical about a vertical plane passing through the vertical axis of symmetry, and bending moments acts in that plane. This assumption is for simple bending. So I have divided in 2 parts. In the first part, there is a simply supported beam, a point load is there, and its cross-section area is a square or rectangle. Now in the second numerical, again simply supported beam, there is a UDL and the cross-section area is a T section. Now in the right hand side of there is again 2 numericals. Numerical number 1, simply supported beam having a point load of 20 kN and its cross-section area is a rectangle having its dimensions is 80 and 100 mm, but the load is applied at an angle of 30 degree with the vertical plane. Now in the second numerical, you will see there is again a simply supported beam. There are 2 point loads and the cross-section area is L shape. You have 2 types of diagrams. Now simple, you can differentiate between these 2 types of numerical. In the left hand side, this is the case of simple bending. Simple bending, it means the plane, the section is symmetrical about a plane passing through vertical axis of symmetry, and bending moment acts in that plane. But this assumption is not valid for unsymmetrical bending, because this is the load which is passing through the centroid of this cross section area. It has two components, one along the vertical axis, second along the horizontal axis. So this violates the first condition, and in the second section, this section is not symmetrical, so this is violating the second case. So we can say that either bending moments do not act in a plane of symmetry of the member, or the section is not symmetrical, or both. In these cases, the beams or questions comes under the unsymmetrical bending condition, and its numerical we can solve in the same manner as we have solved the numericals in case of simple bending. Formula will be same, sigma by y, m by I, E by r, but some other concept will be applied there. And when we apply the loading this type, the section is like this. The upper part of the filament bears a compressive stress, and the lower part bears a tensile stress. This concept we will apply here also. So this is the basic difference, or I can say how simple bending differs from the unsymmetrical bending. And in the next lecture we will solve one numerical that is given in your right hand side. Thank you.